Okay, so good afternoon, everyone. Welcome back to the second session of the Chemistry Olympiad training. Today, we will be going through atomic structure as well as ionic bonding, which should hopefully be some revision that's useful to you if you're in Sec 4, as well as if you have just learned atomic structure and ions in Sec 3. So let's quickly go through a recap. What is inside an atom? An atom is made up of three types of subatomic particles, namely the protons, neutrons, and electrons. These three subatomic particles differ in terms of their relative charge and relative mass. Now, the keyword here is relative. This means that it's not an absolute number. Okay, it's not an absolute number. That means the mass of a proton is not 1 gram. It's not. It's not an absolute number. It's not measured in grams. However, relative means it's a comparison. So what we mean to say is that a proton and a neutron both have the same mass, which is 1. Relative, compared to each other, they have the same mass. However, if you notice, an electron has a relative mass of 1/1836. This means that an electron is 1,836 times lighter than a proton or neutron. Okay, so it's all relative, comparing. Are you heavier or are you lighter? Similarly, in terms of charge, it's also relative. Protons have a positive charge. Electrons have a negative charge. Whereas neutrons do not have any charge. Okay, so hopefully we remember this table well. Hopefully we also remember the locations of each of these particles in the atom. So the protons and neutrons are found inside the center called the nucleus. And that's why collectively, the protons and neutrons are called the nucleons. Nucleons means the particles inside the nucleus. So what is inside the nucleus? There are only two types of particles: protons, neutrons. So protons plus neutron is called the nucleon. Okay? On the other hand, your negative electrons are found in the electron shells around the nucleus. So this is a quick recap of what you have done in Sec 3, Term 1 under atomic structure. Okay? Next. So you have also learned some important properties of atoms. For example, you have learned since lower sec, atoms are electrically neutral, meaning atoms do not have a net charge. If you look at a carbon atom, it's neither positively charged nor negatively charged. It doesn't have an overall charge. And the explanation for this is that the number of electrons inside an atom is equal to the number of protons. Now, this tells you it's an atom. So if we were to give you a question whereby we give you number of proton, number of electron, number of neutron, you look. If the proton and electron are the same in number, it's an atom. However, today we will also be doing ions. In ions, the number of electrons do not equate to the number of protons. And that's because ions are formed when atoms lose electrons or gain electrons. So by definition, the number of electrons in an ion cannot be the same as the protons. Okay? Next, we often say the second property, the mass of an atom is concentrated in the center, the nucleus. Why? So if you think back, the nucleus contains protons and neutrons. Protons and neutrons have a relative mass of 1. Protons and neutrons are heavier than electrons. So virtually all the mass is due to the protons and neutrons. Therefore, we say often that the mass of an atom is concentrated inside the nucleus, in the center. Okay, so these are just some quick recaps for all of us. Okay, also important for us to know the difference between atoms and ions. Okay, atoms is where the electron and the proton are in the same number. Okay, and as a result, atoms are electrically neutral. They do not have an overall charge. Okay. Now, very often you also see questions like these. How are the protons, electrons, and neutrons deflected inside an electric field? So what does it mean by electric field? Well, an electric field can be generated by having charged metal plates facing each other, like what you see in the diagram. We have two plates. First plate on top is negative, second plate at the bottom is positive. All right, so these two plates facing each other creates an electric field. An electric field is a region of space where charged particles can be deflected. For example, protons. How will the protons be deflected? Protons will be deflected towards the negative plate. So you can see protons. So this is proton. P plus means proton. The protons are deflected upwards towards the negative plate. Okay. On the other hand, the electrons, E minus is electrons, is deflected downwards towards the positive plate. On the other hand, neutrons are undeflected. So why are neutrons undeflected? And that's because of the charge. Neutrons do not have charge, therefore they are not deflected inside an electric field. So this is quite a common extension question that you see in pure chemistry exams as well. Now, something I want to add. If you notice, the angle of deflection is just not the same. So angles are usually measured in theta. So protons have a smaller angle of deflection. What that means is that yes, the protons are deflected, but they are deflected to a smaller extent. Their path is not so sharply curving. On the other hand, electrons, if you look, they have a larger angle of deflection. You can see that from the curvature of the path taken by the electrons. So what is this deflection due to? Now, this deflection is proportional to the charge to mass ratio. What this means is that electrons have a smaller mass than protons. So electrons will be deflected more than protons as electrons have a smaller mass. Okay, now we will not go very deeply into charge to mass ratio today. We will go deeply into charge to mass ratio when we do metallic bonding later on. Okay, but charge to mass ratio is something that you will encounter again and again, especially if you do more chemistry later on, be it in JC at A level or in poly if you do chemistry related courses. You will realize this concept of charge to mass, charge over mass, keeps coming out. Okay, so therein lies the first question. Deduce which of the following particles will be deflected more. Okay, to do this question, you will need a periodic table because that's where we get the mass from. Okay, I hope you know by now, masses can be obtained from the periodic table. So now, if you have a periodic table nearby, please take it out. That will help you answer question 1, A, B, and C. Okay, remember, the deflection is proportional to charge over mass. Charge over mass. So you need to know the charge, which is shown already. You need to know the mass. Mass comes from the periodic table. So maybe I can give you 30 seconds to quickly work this out. Question 1, A, B, and C. You will need to find the mass from the periodic table. So for example, 1A, you need to look where's lithium. What's the mass of lithium? What's the mass of sodium? Find it, then let's work it out. So 30 seconds starts now. Okay, so I hope you are working on 1A. You should be able to find the mass of lithium and sodium. Okay, 10 more seconds. Okay, think through what's the mass, think through what's the charge. Remember, the deflection is proportional to charge over mass. Okay, so now can I invite those in the Zoom room to just type in the chat? For 1A, which particle is deflected more? Is it Li plus or is it Na plus? Just type in the chat. Okay, I see 2 responses. How about the rest? Okay, 4 responses. Okay, 5. Okay, good. Okay, so most of you have responded. Okay, so for 1A, which particle is deflected more? The answer is Li plus. Okay, why? Li plus is deflected more as it has a smaller mass than Na plus. Okay, so if you go to the periodic table, you search lithium. Lithium has a mass of 7, whereas for sodium, the mass is 23. So you can tell that lithium definitely has a smaller mass. So since the deflection is proportional to charge over mass, mass is smaller, deflection is larger. So Li plus has a larger deflection than Na plus. Next, we have F minus and O2 minus. Okay, which one is deflected more? Can I invite you to type in the chat as well? F minus versus O2 minus. Okay, I see 1 response, 2. So think through it. Okay, deflection is proportional to charge over mass. So if the charge, are they the same charge now? Okay, so I see quite a few responses for O2 minus, and that's correct. Now, O2 minus is definitely deflected more, and that's because it has a larger charge. Now you must be wondering, oh, but 2 minus is more negative, right? So how can you say the charge is larger? When we say larger charge, what we mean is that the magnitude, not the sign, the magnitude of the charge, how big the charge is larger. So O2 minus is more negative, meaning it has a larger negative charge. That's why it's deflected more than F minus, okay? So finally, with the last one, we have K plus and Mg2 plus. So let's go. Which particle is deflected more in 1C? Is it K plus or is it Mg2 plus? Okay, let's type in the chat, Mg2 plus or K plus? Okay, so many responses are coming in. This one seems very clear-cut to most of you. Is it K plus or is it Mg2 plus that is deflected more? Okay, keep the responses coming in. Great. I see more responses coming in. Okay, great. Most of you chose the right one, which is Mg2 plus. Now, obviously the reason is because it has a higher charge, a larger charge. All right, but that's not the only reason. If you were to look deeper, okay, look deeper at the masses as well. Okay, you look deeper at the masses. Mg2 plus has a larger charge and a smaller mass than K plus. How do I know that it has a larger charge? You compare. Mg is 2 plus, it's a double positive charge. Compared to K plus, definitely a 2 plus is a higher charge. Besides that, if you look at the mass, magnesium's mass is 24 Mg. You look at Mg in the periodic table, the bigger number is 24. So magnesium has a larger mass, a smaller mass. Potassium's mass is 39. So potassium has a larger mass. Magnesium, smaller mass. So if you look at it, Mg2 plus, larger charge, smaller mass. So charge over mass is bigger. The deflection is also bigger. Okay? Now, Mg2 plus is also interesting. If you do more chemistry later on, you will realize that the group 2 ions, group 2 means magnesium, calcium ions, they all have higher charge than the group 1. And they tend to have slightly different properties as a result of this higher charge. Okay, but that one is later on if you do more chemistry at A level. Okay, so that's question number 1. Just a quick introduction on how the deflection in an electric field works. Okay, hopefully for the Sec 3s, you have also seen something similar before, be it in your practice questions or maybe even in the recent assessments that you have had. Okay, question or section 3, which is about proton number and mass number. So this is how we make use of the periodic table to get the information that we need. So if you go to the periodic table, you will find your element symbol, the element name, as well as 2 numbers associated. The top number, which is a smaller number, is known as the proton number or the atomic number. All right. So the smaller number gives you the number of protons. This one I think your teachers have explained to you. But why call it the atomic number? Atomic number is also the proton number, by the way. It's the same thing. So for iron, the atomic number is 26. But why call it atomic number? It is called the atomic number because every single element has a unique atomic number. It is like the IC number of the element. If you tell me atomic number 26, I will know that it's iron immediately. Because no other element in the periodic table will have atomic number 26. No others. Okay? And this leads us to an important conclusion. Elements are found in the periodic table. The elements all have their own unique atomic number, which means that elements are arranged in order of atomic numbers in the periodic table. So if you look at the periodic table now, don't you realize that the atomic number is in consecutive running order? So it tells you that elements in the periodic table are arranged in order of their atomic numbers. Okay? So on the other hand, we have the larger number, which is the mass number. So the mass number tells you the number of protons and neutrons. So added up, protons plus neutrons equals mass number. The mass number is also known as the nucleon number, which is what Mr. So explained just now. The nucleons are your protons and neutrons. Okay? So I'm sure the next word example you are familiar. Unfortunately, there's a typo error. It's not sodium atom, it's iron atom. This is iron. So in iron, you have 26 protons because the proton number is 26. If you have 26 protons, you must also have 26 electrons because in an atom, they must be the same number because atoms are electrically neutral. Finally, how do you find number of neutrons? You take the larger number, which is the mass number, minus the smaller number, the proton number. So 56 minus 26 gives you 30. So an atom of iron contains 30 neutrons. Okay, so up to this stage is a quick recap of what we have done so far in atomic structure at O level. Okay, at this juncture, before we move on to section number 4 on page 4, if you have any questions you would like to ask, you may wish to unmute yourself. Otherwise, you could type in the chat. Okay, maybe I'll allow 30 seconds for any questions. How do you find the charge that an atom would form, right? Okay, that one we will go on to later, okay? When we talk about ions. But so far, do we know how to read the periodic table to get these information? Hopefully we are familiar with these two numbers, the proton number and the mass number. Okay, if not, I'm going to go on to section 4. Now, section 4 is what you have done, but now we're going to take it one notch higher. We're going to learn how to write electronic configurations using shells and subshells, which I will explain in a short while what they are. But I hope you know by now, chemistry is all about electrons. Even though we learn, oh, atoms contain protons, neutrons, and electrons, the whole of chemistry is essentially about electrons. Where are electrons found? How many electrons are there? How many electrons are there in the outermost shell? How many electrons are lost? How many electrons are gained during a reaction? And for my Sec 4 students, I hope you realize the entire foundation of redox and electrolysis is about electrons. Are the electrons lost or gained? So you can see electrons really dictate all the chemical reactions that you have learned and that you will learn in future as well. So it's important for us to understand electrons, understand how electrons are arranged. How electrons are arranged, that is called the electronic configuration. So electronic configuration is a very profound word that simply means how electrons are arranged. Okay? So first we need to know electrons are located in the shells, electron shells. The closer the shell is to the nucleus, the more strongly attracted the electron will be. This makes sense. The nucleus contains protons. Protons are positive. They attract the electrons. So if the electron shell is near the nucleus, the attraction is stronger. Okay? Finally, I believe your teachers would have taught you each electron shell accommodates a different maximum number of electrons. It's not random, there are rules to follow. The first electron shell, which is closest to the nucleus, only can accommodate 2 electrons. The second shell accommodates maximum 8. Third shell usually fills 8, though it can accommodate up to 18. So how do we apply this? For example, sodium. If you look for sodium in the periodic table, it has the chemical symbol Na. Sodium, if you look for the numbers together with the element, sodium has 11 protons And because of that, it will have 11 electrons. So how are these 11 electrons arranged? First shell, 2. Cannot exceed 2. First shell can only have 2, right? Second shell, 8. So 2, 8. But if you think about it, 2 and 8 together makes 10. 10 electrons, but I have 11. So I need one more in the third shell. So we say that the electronic configuration of sodium atom is 281. This is how it's written. And we realize, oh, this means that sodium has one valence electron. What does valence mean? Valence, simply put, is outermost. In the outermost shell of sodium, it will have one electron. So we say sodium has one valence electron. This is an important property. Okay, so you can repeat this analysis for, say, magnesium, calcium. Okay, and that's what you have been doing in class, right? You've been writing out the electronic configurations, making use of these rules. First shell, 2 electrons. Second shell, maximum 8. Third shell, also maximum 8. However, as we will see today, actually the third shell can accommodate up to 18 electrons. So today we shall answer this question. Why so strange, the third shell? Why is it only filling up 8 electrons even though it has the capacity to accommodate up to 18? This shows you that shells may actually be further divided into subshells. A shell can comprise many subshells. And perhaps that's why, because we fill 8 first, then we fill the rest later on. That means some subshells are filled first, other subshells are filled later. Okay? And that is what we'll go on to today. Each shell is further divided into subshells, and each shell has a different number of subshells, which you'll see in this table here. The first electron shell, this is closest to nucleus. The first shell only has one subshell called the 1s. Wow, why call it 1s? So the number in front tells you what is the shell. 1 means first. 1s means first shells, s subshell. 1s means first shells, s subshell. So the s is the type of subshell. Okay? So 1s subshell accommodates 2 electrons, and that's why the first shell only got 2 electrons maximum, because there are no other subshells in the first shell. The second shell is more interesting. The second shell has 2 subshells, 2s, 2p. So what does the 2 mean? The 2 means second shell. So 2s means the second shell's s subshell. All right. Now you realize s will always have only 2 electrons. But then once you get to p, is a different story. P accommodates 6 electrons maximum. And that is the reason why your teachers would have taught you in class. The second shell holds a maximum of 8 electrons. Because the second shell has a 2s subshell, it has a 2p subshell. 2s is 2 electrons, 2p, 6 electrons. So 2 plus 6 equals 8. 8 electrons in total in the second shell. Then we move on to the third shell. The third shell has 3s, 3p, 3d. 3s also 2, 3p, 6, 3d, 10. I'm sure you can start to see the number pattern, right? S, 2, P, 6, D, 10. So you're always adding 4 electrons from one subshell to the next type of subshell. Okay? And so we say the third shell can accommodate a maximum of 18 electrons. 2 plus 6 plus 10. Finally, the 4s, 4p, 4d, 4f. So you can see F, once you get to F, it can accommodate 14 electrons. Okay? Can? So this is the idea of shells that you have learned at O level. O level, you learn shell, first shell, second shell, third shell. But now you have to learn each shell can be further subdivided into subshells. And because the shells are all different, they will have different subshells. And importantly, you have also learned at O level, when you want to write and fill the electrons, you fill from the lower number first. You fill from the lowest energy level closest to the nucleus first, meaning we will fill the first shell first, then the second shell, then the third shell, right? So just like just now, Mr. So wrote 281. First shell 2, second shell 8, third shell 1. I go in order. Now, this concept, this principle of filling up electrons in order is called the Aufbau principle. Aufbau is a German word. It means building up. I'm building from the first shell to the second shell to the third shell. I fill from first shell to second shell to third shell. All right? So there's an order to follow. Now that you have learned subshells, you need to know the order. The order is you go from 1s to 2s. So you start from 1s first, then you go to 2s. Then from 2s finish already, then go to 2p. 2p finish already, then go to 3s. Then 3p. The difficulty is here. After 3p, you'll be tempted to go on to 3d, right? Because it's third shell, ma. But as it turns out, the 4s is filled before 3d. And this is the reason why your teachers would have taught you the third shell fills up 8 electrons first. How come I get a magical number 8? Because 3s has 2 electrons, 3p has 6 electrons. So if I fill 3s 2, 3p 6, I will fill up 2 plus 6, 8 electrons in the third shell first. Okay? Can? So it's not wrong what Miss Miss Shahida, Mr. So, Mr. Lee have taught you all. It's not wrong. The third shell will fill up 8 electrons first. Okay, and that's because at O level, you don't learn this concept of subshells, but now I'm teaching you. Okay, now, so how is this useful? How is this applied? Let's practice. So, if you are given an iron atom, iron has 26 electrons. How on earth would you write this? Well, you will write it in SPDF notation in this way. 26. I have 26 electrons to fill. How do I begin? I begin with 1s. It must start from 1s. 1s can fill how many electrons? I look at the table. 1s takes up 2 electrons maximum. So I write 1s2 in this way. You notice now the electrons are the 2 electrons is written as a superscript on top. So 1s, 2 electrons. Then after 1s is fully filled, we go to 2s. 2s is also s. S is always 2 maximum. 1s2, 2s2. After 2s is done, you go to 2p. 2p, 6 is the maximum. 2p is done, you go to 3s. 3s. S again is 2 is the maximum. After 3s is done, you go to 3p. 6 is the maximum. So at this stage, right, you gotta start counting 2, 2, 6, 2, 6. If you add up 2, 2, 6, and 2 and 6, 2 plus 2 plus 6 plus 2 plus 6, this will give you 18 electrons. Okay, don't believe you try. 2 plus 2 plus 6 plus 2 plus 6 is 18. Iron has 26 electrons. So how? I have only written 18 leh. I must write another 8 more. How to write? So you must know this property. 3P finish already is not 3D, it's 4S. You notice Mr. So has left a spacing in between. I know I must leave a spacing in between because I need to write 3D later on. So I leave a space. Okay? So even though I fill 4S first, I must still leave a spacing to write 3D later. So 4S, S again is 2 electrons. So now you count lah. 2 plus 2 plus 6 plus 2 plus 6 plus 2. So I've written 20 electrons. So therefore, the last 6 electrons will go into 3D 6. Okay, so that's how you write the electronic configuration of iron. Okay, and for the 3 contribute students, you have probably learned today what is iron 2 ion, iron 3 ion. Hopefully we know the 2 and the 3 means the charge, right? So why does iron form 2 plus and 3 plus? Why so different the charges? And the reason is because iron has electrons in the D subshell. So iron can choose to lose 2 electrons to form 2 plus, or iron can choose to lose 3 electrons to form 3 plus. And that's the unique property of iron, as well as other elements that have this Roman numeral. So you have learned iron 2, iron 3. I believe you have also learned copper 2. Okay. Can? Now, there's no better substitute than to practice. In the interest of time, let's just do E and F. These are the hardest. So let's do E and F. Okay, Mr. So will help you. Mr. So will tell you how many electrons they have. Titanium, 22 electrons, 2, 2. Bromine, 35 electrons. So let's start writing titanium and bromine. How will the electronic configuration look like? Okay, let's try writing for titanium and bromine. Don't do for the first few. So remember, always count the number of electrons and total it up. Make sure it's correct, okay? Like just now what I did for iron. Okay, now titanium has 22 electrons. So you might want to make sure you add up the 22. Okay, I just give you 30 more seconds to slowly work out. Okay, remember you must go in this order, right? Must start with 1s, finish 1s first, then go 2s. Finish that, then 2p, and so on and so forth, okay? Okay, cannot start with 3s first, you must go from 1s, then 2s, then 2p, okay? So the person will just message me. You want to think again? Then remember, after 3p, where do you go to next first? Okay, so let's start. Okay, so now Mr. So has written out the list already. So let's go one by one. So we must always start with 1s first. 1s, read the table. 1s fills only 2 electrons. So 2. 2s is the next one. 2s, how many electron? 2. After 2s, what's next? 2p. P, maximum 6. So again, 1s2, 2s2, 2p6. After 2p, what's next? Then you read. After 2p is 3s. S, again 2. 3s2. Then after 3s, what's next? 3p. 3p holds 6. So I always find it helpful. After I finish the 3p, I start thinking, okay, let's total up what we have written. 2 plus 2 plus 6 plus 2 plus 6. That gives me 18. Right? So I've written 18 electrons as it is already on the screen. But titanium has 22 electrons. And therefore, I need to go on. How many more do I need to fill? I have written 18, but titanium has 22. So I need to fill 4 more electrons. So now I need to be careful because I need to know that after 3p, what comes next? So I read from the diagram above, we can see the order of filling up is after 3p is 4s. 4s. 2. Then I know, okay, so 4s holds maximum 2, so I put 4s2 first. I do the 4s first. After the 4s is done, then I come to 3d. So now if you calculate, okay, how many should I put into 3d? Okay, let's ask someone to type in the chat. How many electrons should Mr. So put into 3d? Maybe Andre or Audrey, can you type in the chat how many electrons should I put into 3d? Two, right? Then you will total out to 22, right? Okay? Now, this is important. So when you learn chemistry, don't just learn things one by one. Of course, you must learn how to fill out the electronic configuration. But I hope you know by now, things can lose and gain electrons, right? So titanium. What is titanium's valence shell? The valence shell is this one. The fourth shell is the outermost, definitely. There are 2 electrons. So instinctively, you know, titanium will form Ti2+. How I know 2+? Because titanium can lose the 2 electrons in the 4s. So titanium indeed forms many compounds whereby it has a 2+ charge because it loses 2 electrons. And the 2 electrons came from 4s. However, the interesting property with these 3D, the 3D is always very troublesome. The 3D can also be lost. As a result of that, titanium not only has Ti2+, titanium also has Ti4+. How do I get 4+? I get 4+ when titanium loses the 2 electrons in green in 4s. and the 2 electrons in blue from 3D. All right, so that's why you can easily predict titanium forms Ti2 plus and Ti4 plus. These are the most common. Titanium also has Ti3 plus. That's another common one. Okay, but less common than the 2 plus and 4 plus. So for my 4 contribute students, this is how you actually predict that titanium has 2 plus and 4 plus. Okay, now let's move on to bromine. Okay, let's do the same. 1s, 2s, 2p, 3s, 3p, 3d, 4s. Okay, and that's not it. Bromine has until 4p. So we go one by one. 1s2, 2s2, because s is always 2. 2p6, 3s2, 3p6. So up to this stage, 3p is a good time to take a pause and think through. Okay, Mr. So has written 18 electrons, but bromine has 35. I've only written 18, so I need to write 17 more. 4s2 is next. 3d10 is next. All right. So if you calculate, okay, 2 plus 2 plus 6 plus 2 plus 6 plus 10 plus 2, I've written a grand total of how many? 30, right? 30. And that's why 4p5 is the last one. Okay, so just check that you can write this. Okay, I know it's not easy. Okay, it's also not easy for the A-level students when they first learned it. Okay, so you learned it slowly. Okay, it's okay we don't finish this set of notes, but we learn things slowly. Now, then you must be wondering, now if you look at your periodic table, it doesn't look right? How 4p5? Does it mean that bromine has 5 valence electrons? But didn't my teacher tell me that bromine is in group 7 for the sec 4s or group 17 for the sec 3s? Surely group 7 or group 17 elements have 7 valence electrons, right? How come Mr. So tell me only got 4p5? So what is our concept of valence? Valence means what? Outermost shell. I never say subshell. Outermost shell. So what's the outermost shell? The outermost shell is the 4th shell. What? And that's why we say bromine has 7 valence electrons. Because the 7 comes from the 4s and the 4p. The outermost is the 4th shell. The 4th shell has the 4s and 4p. And that's how I get 2 plus 5 electrons, 7 valence electrons. That's why bromine is in group 7 or group 17. Okay, depending on whether you're sec 4 or sec 3, the periodic table is slightly different. Okay, so that brings us nicely on to the next section. I hope you're still following me. Now, after talking about subshells, so where on earth are the electrons located, right? Like what space are they in? Is a shell like a piece of onion? Okay, is it round? Now, the answer to this is actually very, very complicated. Now, where are the electrons in an atom located? We can not say exactly, definitively, it's here. The electron is here. We can't say that. All right. So the answer is that electrons don't occupy a clearly defined space. Scientists can only say that electrons are most likely to be located in this space. But where exactly in this space, we don't know. We can only give you a probability, a likelihood. All right. And so this space where electrons are most likely to be located is called orbitals. So actually orbitals are where electrons are at. So in short, we learn shell. Shell can chop and divide into subshell. Each subshell can chop and divide into orbitals. All right. Now I'm not going to go deep into orbitals today, but just know that orbitals have shapes. So that's why S has a certain shape, P has a certain shape, D has a different shape. And that's why if you go on and do more chemistry, you will learn that this is the reason why your molecules have shapes. Things are not flat. Things have shapes. Okay? Can? Now you can see what it sounds like maths. What? X squared minus y squared, z squared. You are right. This is maths. All right? If you go on to do more mathematics at A level, let's say you take further mathematics, you will learn the type of mathematics that you need to solve for equations, and the solution to the equation gives you the shape of these orbitals. All right. So right now you're doing A maths, right? A maths, you learn quadratic. Oh, you know, when you solve quadratic equations, sometimes you get 2 real roots. What does 2 real roots mean to you? How do you use these roots to the equation? All right. So when you go on and do more mathematics, then you will learn more and more complicated equations. And when you solve them, actually, the solutions to those equations, the roots to those equations, actually gives you the shape of orbitals. All right. But this is university level already. Okay, moving on. Let's go on to next one. First, ionization energy. How easy is it to lose electrons? So hopefully we know by now, atoms can lose or gain electrons. And the whole purpose of losing or gaining electrons is to achieve a fully filled outermost electron shell. This is like the ultimate purpose for all atoms in the periodic table. If they don't already have fully filled outermost shell, they will want to lose or gain valence electrons. Good example is sodium. Sodium, if you read, sodium 281. Oh my goodness. It has one valence electron. It's not fully filled. So what is it going to do? Sodium will lose one electron to form Na+. By losing the one valence electron, now your outermost shell, which is the second shell, is full. Because second shell can only have 8. That's fully filled already. All right. So when you lose electron, you must have energy for this. So the first ionization energy is the amount of energy needed to remove the electron from the atom to form the singly positive ion. Singly positive means 1 plus charge. Single positive charge. Okay? Oh, so now you know there's something called first ionization energy. The first ionization energy is the energy required to remove the first electron from the atom. Where does this electron come from? The electron comes from the outermost, the valence shell. So, is the first ionization energy going to be the same for all elements? Clearly not. If you think about it, the valence shell can change, right? If you look at a single group, let's say group 1, lithium, sodium, potassium. Lithium, the valence shell is the second shell, you know. Sodium, the valence shell is the third shell. Potassium, the valence shell is the fourth shell. So quite clearly, you are talking about different shells. You are talking about removing the electron from a different kind of shell. Second shell, third shell, fourth shell. So what can you say? As you go down the group, the number of shells will increase. As a result of that, the valence electron is located further from the nucleus. That makes perfect sense. As you go down the group, they got more and more shells. What? If there are more and more shells, the valence electron must now be further away from the nucleus. Further away, so less strongly attracted. Valence electrons further away, less strongly attracted. And so the electrons are more easily lost and require less energy to be removed. Hence, the first ionization energy decreases. All right. And this also explains to you why group 1 elements become more reactive down the group. So potassium is very reactive. Potassium is more reactive than lithium. If you throw lithium into water, it doesn't catch fire. If you throw potassium into water, it catches fire and can explode. All right. So my 4 contribute students, I've demonstrated this to you in the lab. We threw potassium into water, it caught fire. Whereas sodium doesn't. All right. This shows you that potassium is more reactive than sodium. Group 1 elements become more reactive down the group. Because of this reason, it becomes easier and easier to lose the valence electron. Okay. Now, across a period from left to right, first ionization energy generally increases. That means when you go from left to right, the elements find it harder to lose electrons. That makes sense because you have just learned metals are on the left. Metals lose electron. So sodium lose electron, calcium lose electron, magnesium lose electron. On the other hand, the non-metals are on the right, like oxygen. Oxygen gains electrons. Chlorine gains electrons. All right. So why is this so? That's because as you go across a period, the number of protons increases. So they got more and more protons in the nucleus. If you got more and more protons inside the nucleus, there are more protons to attract. the valence electrons strongly. And so the valence electrons become harder to lose. You need more energy to remove electrons from elements on the right-hand side of the periodic table. And this explains to you why elements on the right tend to gain electrons instead of losing them. Okay, so finally, oh, but you know, Mr. So, you only say lose the first electron, right? But some elements can lose more than one electron, right? That's true. So you can continue to define the second ionization energy of an element. The second IE of an element is the energy required to remove the second electron. That means you already have plus. You want to go to 2 plus. You want to remove the second electron. Okay? Okay, please pardon me. It's supposed to be an arrow. I have no idea why OneNote has converted it into this star thing. Okay, it's an arrow on your notes as well. Okay, so the second IE is the energy required to remove the second electron. Then you're like, what? Doesn't sodium just lose one electron? Well, let's look at the numbers. The first IE is 494. See, sounds reasonable, huh? The second IE is, oh my God, so much higher, huge increase. Which tells you that sodium needs a lot of energy to take away a second electron. Why? Because the second electron is from the inner shell already, right? Sodium only has one valence electron. So the second electron, if you really want to remove a second electron, is from inside. If it's from inside, it's so much closer to the nucleus. Needs so much more energy to be removed. Then now you think, if you are sodium, would you even use so much energy? No, you won't. And that explains why sodium only forms Na+. You have never ever heard of Na2+, because sodium needs so much more energy just to lose a second electron. So sodium won't do that. Sodium will just do lose one electron, forms Na+. All right. So I think we will end off with question 3 today, but just let me quickly go on to ionic bonding after this, which will take about 5 minutes. But let's look at question 3 first. Now, I've shown you the first ionization energy, the second, the third, and the fourth. So now I want you to work out how many valence electrons does element X actually have. So just now we worked out, we look for the huge increase. I want you to work out where is the huge increase, from which to which is a huge increase. Where is the largest increase in the number? Maybe someone can type in the chat. From what to what is the huge increase? Second to third, right? Do we agree? Like just looking at the numbers, the magnitude of the numbers, wow, the huge increase is second to third. So let's write that down. There is a huge increase from the second ionization energy to the third ionization energy. So what does this actually mean? Second IE means remove second electron. Third IE means remove third electron. So what does this mean? It means that the third electron, third IE, right? The third electron requires a lot more energy to remove. That's why the third IE is so high, right? So why would the third electron require a lot of energy to remove? This means that the third electron is no longer from the outer shell. The third electron is from the inner shell. So X, how many outer electrons did it have? Does it have 3 outer electrons? No, right? How many outer electrons do you think X has? Can someone type in the chat? How many outer electrons does X have? Maybe Tiha, Or Sydney, you can type in the chat, how many outer electrons does X have? Based on what Mr. So has written. How many outer or valence electrons? Pia or Sydney, can you type in the chat, how many outer electrons does X have? 2. So if something got 2 valence electrons, it means that X is from group number 2. Okay, you'll notice throughout this training, right, I have to use 2 different ways of naming. So because the sec 4s, you are following the old periodic table, so your 2 is written with a Roman numeral. For the sec 3 students, you are using the new syllabus, so the new periodic table uses a regular numeral. Okay, so X is from group number 2. That's how you predict. You look for the huge increase, then you rationalize in your head. Huge increase means what? Oh, the third electron must require so much more energy to remove. That means the third electron must be super inside, inner shell. That means outer shell originally only have 2 electrons. So 2 valence electrons, X from group 2. Okay? Now, I will just take about 8 minutes. I will just quickly go through ionic bonding on the next page. I will leave page 11 and page 12 for the following session to go through, which is also good for the 3 contribute students, because over next week, you will be also learning about ionic bonding and ionic compounds. Okay? So let's go on to page 10. Now, I hope you know by now, when things lose and gain electrons, they form ions. So what are ions? Ions are charged particles. And how do they form this charge? They form the charge because charged particles formed when atoms lose or gain valence electrons. Okay, and this is important. Metals lose valence electrons and they form positive ions. Lose electrons, it becomes positive because electrons are negative. You lose negative charge, so you become positive. So lose, you become positive. On the other hand, non-metals gain valence electrons, they form negative ions, okay? You gain electrons, you form negative ions. Okay, so this is magnesium chloride. As you can see, magnesium forms 2+. How you know it forms 2+? Mg is group 2. And because it's group 2, it loses 2 valence electrons to form the ion with a 2+ charge. How do I know that Cl is minus? How do I even work that out? I work that out based on chlorine's position. Chlorine is from group 7 or 17. Okay, give me a minute. Chlorine is from group 7 or 17. So it gains 1 valence electron to form Cl minus. Okay? Now, this forms a compound, obviously, because the positive ion is attracted to the negative ion, and this is called a strong electrostatic force of attraction, which is what we call the ionic bond. Okay, so we will stop here. I will go on to the ionic bonding in further detail next week. All right, so let me just stop the recording here. Thank you.